Don't hate the player, hate the game, okay? Hey, we're back here on the Gasser 55 project. Gonna get you some, Mike.
For those who don't know, we are rebuilding my 1955 Chevy Bel Air. Into a street beast, really. 990 car, 700 horsepower, and make sure it's super reliable so I can just cruise the track, race, go back home. First episode, I called out Mike Finnegan. For those who don't know who Mike Finnegan is, he's over Hot Rod Magazine. He's the host of Roadkill, and he has a pretty cool 55 called Blasphemy. I don't know, show some footage, clips of it, whatever. So I called him out to a race. He actually accepted, and then to be determined day and time, we will be racing the 55s against each other.
So what are you working on today?
We are going to assemble the motor. We're basically going to take all the parts that we've gotten from our great manufacturers, and CPR did all of our machine work for our block. CPR is Custom Performance Racing. If you go to our tracks locally and you see a fast build, good chances are CPRs who did their heads, who did their bottom end, who put their motor together. And we are going to completely assemble the short block, meaning the cast iron case, the crank, the rods, and the pistons. That's all there is to a short block.
Cool, man. I'm excited to learn something new.
Well, hopefully after all this is done, everybody in the shop will feel comfortable around an LS. At least they can at least point at it and know what it is.
You just ruined it. That was a surprise. That was the whole surprise, dude. So we ended up going with, yes, an LS. I'm gonna go back to drawing now. Brad, thank you very much. It's nerd alert. He's gonna get super nerdy, so keep your notebook out, make notes, timestamp it, whatever. I gotta go do my thing.
If you take everything I say into consideration, you might be able to build a pretty nice LS motor. So watch and learn. All right, guys, we're back here in the garage today to get John's motor assembled. We spent all day yesterday at CPR. Thanks, guys. Really appreciate you guys having us. Well, today in the garage, we're gonna take everything that we got done from CPR and assemble it. First of all, our crankshaft. Crankshafts are great. They come out of the box pretty damn perfect. But when you're building a race motor or a spec motor, you take perfect and you bring it to one more level. What we did is we had it balanced. Balancing means they set this thing up in a machine and they drill these holes in here and they balance this thing. When they're done balancing it, they actually micro polish all these journals. We can go back to showing you that. And that's phase one of the crank. On the rods, they also did bob weight, meaning they weighed the big end, weighed the little end, and then went ahead, basically sand off the ends in order to match weight. They put these weight with this weight, they add that bob weight to here, and they balance this. So now, we have a spec balanced motor. CPR was nice enough to go over this whole block. This block was brand new, ordered from Summit. The only problem was these bore surfaces and this surface here wasn't exactly perfect, or perfect to, let's say, blueprint race spec. So we took a brand new block, we had the bores matched per piston, as well as we had these surfaces recut so that this surface and this surface match and that they won't have any leakage or any problems at all. So let me grab this thing and show you a few things I did when I first got this block just to make my life easier, and it's things that I was taught by my father to do. Right here, I went and got a black marker and I labeled my cylinder numbers. That way when I'm assembling this, I can always reference what cylinder numbers I'm at. Also, your main caps, they go with that arrow facing the front of the motor. I drew this on here for the simple fact of when I put them back on and take them back off, I don't have to think about it. I know all those arrows go in that same direction. As well as, these are numbered. we know what order they go in, as well as what direction they need to head. Let's go ahead and get these things apart, get these things cleaned up, and get that crank in there. We want to spend the extra time making sure that we have all our clearances, and the clearances are for lubrication. That's why they give you the clearances. That's why you need the clearances. If you don't use proper clearance in your motor won't lubricate, it won't last, and you'll wear everything out. So our next step is to plastic gauge all of our mains. See that little piece of plastic right there? That little piece of plastic we're gonna smash, and then we're gonna measure against this. And this right here, see that 015 and that 020? As long as we're somewhere in between there, we're gonna be okay. So let's go ahead and put that on, clamp it down, and figure out what it's at. All right. I'm gonna go ahead and give you guys the once over on torque to turn versus torque foot-pounds on a torque wrench. This is a turn to tight wrench. You set your base up so it's permanently sit still. Then you loosen up your little set screw right here, and you put this little guy right here, needs to go to 0. So we're just gonna turn her right there, and we need to turn this bolt to basically being in the inner bolt 80 degrees. We're just gonna go ahead and make a little mark. It's gonna be right about here. So we need to turn this bolt to 80 degrees. Oh, that was sucky though. I bumped it. That's all right. Now, the big thing is when we're doing this with, these are factory studs, just to check our clearance. And then we're gonna take these out and we're gonna replace them with ARP hardware. Your oil, this stuff, this great lubricating stuff right here. Let's put some a little right here. Oh, there we go. Those oil right there. If you were looked at that in a microscope, a very big microscope, what you would see is oil globules. They're just little round things like this, oil globules. And what happens is, this is your crankshaft, and it turns in this rotation. This is your bearing. That's this piece. Right here. The oil needs a minimum of 3 globules to protect. All right? 3 globules measured, if you actually took a microscope and you measured these, would consist to somewhere in between these 2 numbers is what 3 oil globules are. So the idea is to be like right there in the middle. You know, like not too skinny and not too fat, but the theory behind that is oil globules. I'm holding that squashed mark up to where it aligns, and see how it's a little skinnier than that 015?
Yeah.
All right, but it's a little fatter than that 020. Okay, 020 is the max. If it was that skinny, that would be close to being a problem. Or if it was fatter than the 015, that would be a problem. But anywhere in between here is okay. If this clearance here is different from this clearance here, that would generally mean that the crank is bent or your machining in your case itself is done incorrectly. So what we're doing is we're taking the stretch bolts and replacing them with the stronger ARP studs and nuts. These are torque to pound, and they have this neat little cheat sheet right here. And it's basically telling us our inner studs are gonna be 60 foot-pounds, and our outer studs are gonna be 50 foot-pounds. All right. This is a torque wrench. This is a different style way of tightening these bolts. Per our instructions, we need to go on our inner studs 60 foot-pounds and our outer studs 50 foot-pounds. So these are our inner studs, these are our outer studs. So as well as tightening those to 50 and 60 foot-pounds, we have to tighten them in a certain order. And if you look right here, this is the order you've got to tighten them in. The reason you have to tighten them in this order is you will bend this crankshaft. Tech tip, and this is building any motor that you guys are gonna build on anything. As soon as you get your main caps in and you get your bolts just hand tightened down, put your crank wrench on it. Go ahead and turn her over. That feel you have right there, like how much pressure it takes, you need to learn and feel that. Because when you start tightening all these bolts up, it's gonna change a little bit, but not much. It should never feel rough. You should never have like a hard part, like where it goes and it just stops. If you do, stop right there, take everything apart and look at it again. This needs to be smooth as ice, just like that. See how this zero's right here? And then the bottom of that 60 mark is right there. So I need to bring that 0 to that bottom of the 60 mark, which is gonna be like right there. So we're at 60 exact foot-pounds. So if you wanted like 61, that'd be 61, 62 foot-pounds. But we're just gonna do 60, then we're gonna lock it. So inner bolts, starting with number 1, which is dead center. Hear that? That's tight. All right, now we're gonna go to number 2. All right, she smells smooth as ice. The key is like, you don't really want to jump on these things like rah, 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 just because this is like the heart. This is like heart surgery right now. Yeah. So before we tighten our next one, let's do a spin again. Go ahead and see what we feel like. Like butter.
Feels good.
Because we got to switch from 50 to 60 pounds, we know this is set up at 60 pounds right now. So what I'm gonna do is what I call the double click. Go back to my first one, double click, and so on and so forth. This is just reassuring that I know these pressures on all these bolts are equal. That is the final torque for those bolts. Great habit to get into on everything you build. It's called marking your bolts. So now I wanna make a mark. And I want that mark to go from the threads into the cap. Reason being is if this decides to move or rotate out, we're gonna see this white mark move from that white mark. If any of these things have spun, we know we've gotta address a problem. A couple things I wanna go over now, you guys, that we wanna talk about on LS stuff. 4-bolt mains. Well, 4-bolt main is this. 1, 2, 3, 4. What LS did is they stepped that up one even more. They add 2 more splice bolts that go in here. So not only are you torque tight here, you've got these guys keeping this cap from even being able to rattle loose. So even if these bolts were to come somewhat loose, this cap couldn't come out unless these bolts fell out. Smack in the front, smack in the back. And that's gonna set basically the thrust. We've opened our ring set package and laid them out. We're trying to achieve these thicknesses. So what we do is we set the depth up to a certain point and we lock it so that it can't move. And then what we're gonna do is we're gonna push this ring up against it so that we know
It's even all the way around.
it's even all the way around. Now that you know it's even, you see that distance in between here and here? That's called the ring gap. That ring gap needs to be measured. So I have my feeler gauges set up. It's basically a 20 and a 24, so I have a 24. I'm gonna try to slide it in between that gap, like this. And that is a little tight. See how it barely gets in there?
Yeah.
If we pull one out, and we just do one, it goes all the way in. So what we have to do is pull this guy out, and this is a ring filer. All right, we're gonna set this down here onto these little roller things so that this can sit against the face, and we're gonna just take off just a little bit of the middle. If this didn't fit in that gland, then you'd need to actually chamfer these and make it a little bit better. So now we're gonna take that same ring, put it back in, and look how we mark this. This is cylinder number 1, rod number 1, piston number 1. And we're gonna build all these in order. See how it's fitting in there good? That's the proper amount. So this ring is now done. And we've got to basically repeat this process to every single hole. We are so fortunate to be working with Wiseco. Wiseco was nice enough to engrave this name right here on the top of their piston. Special things noted for this piston is the top ring gland. This is notoriously made extra strong for the application that we're using. With the type of additors that we plan on doing to this motor, meaning power additors, we need an extra thick ring gland on the very top of the piston. Also, they added these holes. These holes are for the oil to weep back down and fall in through here and come back down. Now they're on the oil ring and on the first ring. These are special pressure gas release holes, keeping that first ring from like expanding and blowing the lip off, as well as it's a coated skirt. This skirt's got this special black coating. That's not for looks. That's to actually slide up and down the cylinder wall and protect it. Basically, orientation of the piston goes like this. See this flat spot right here versus this grooved spot right here? So these flat spots go rod to rod, meaning this rod here, see that flat spot? They're gonna ride like this on this cylinder. So this journal down here carries 2 rods. One goes this way, one goes this way. We're gonna stop that and let you guys time lapse this whole video and watch me get the pistons set up. Trying to keep all the dust and the crap out that's in this warehouse.
All right, dude, so looks good, great work. Everything went together well?
Everything went perfectly. Thank you CPR for all the great machine work. Thank you Wiseco for all the great parts. Can't wait to see this thing fire up and you guys can look at me, make me look like Superman. 2 thumbs up.
Well, it looks like you wrapped this thing up, so you know what time it is.
Oh yeah. That's a wrap!
Little TDC, Total Dead Center.
Top dead center.
What?
Jesus.